Recording in progress.
Okay, so geometric sequencing series. A geometric sequence is simply a pattern where you multiply by the same number over and over and over again. So consecutive terms have a common ratio, whereas arithmetic, the consecutive terms had a common difference, is a common ratio. You can also think of it as dividing by the same number if you want, like you multiply by 2, the same as dividing by half, or something like that, right? Or multiply by half is dividing by 2. Same thing, right? So that's kind of like addition, subtraction are considered kind of the same thing. They still lead to a common difference. Multiplying and dividing still leads to a common ratio as long as you do it consistently. So if you take a future term divided by its most previous term, we call that R. So A sub n plus 1 over A sub n will equal R. So in this case, for example 1, we're going to determine if it's geometric, and if it is, state the value of R. So do I see a geometric pattern for part A? Yes or no?
No.
No, but just adding, right? So that's a no. Yes, it's 2n, but that's adding 2. So that's no. How about B? Yeah, and that's exponential in nature. You need to have an exponential in nature to be a geometric sequence because you're doing 2 or whatever the ratio is to some power, right? So yes, and the R value is going to be 2. And of course, C is yes as well. What's the R value for that one? Negative 1/3. So we see that R is kind of the, not kind of, it is the base of the power, right? How can we come up with the nth term of a geometric sequence? So say, for example, I give you the first term in the common ratio. And you want to find, like, say, the 10th term or 20th term. Let's talk about it down here. So say, for example, you want let's say you want A sub 20. Let's say A sub 1 is like 2, and let's say R is like 3. So how would I find A sub 20? What do you think I would do, guys? 2 is my first term. And how many times do I need to apply the common ratio to go from the first term to the 20th term? It's 19 times. Good. 19 times, yes. Just like the arithmetic sequence, if I want the first one to the 20th term and the common difference like 10, that's add 10 19 times to go from the first to 20th term. This kid's got to multiply 3 19 times. So in general, we could think of it like this. A sub n equals A sub 1 times R raised to what power, guys? N or n minus 1? N minus 1, exactly. Give me n minus 1. That's how we do it. And that's an A. My A's just are look funny. So yeah, that's all. So, and that's an explicit formula. It gets you directly to the term you need. But if you just use some intuition, I know you guys can figure it out, right? Without really memorizing the formula. So first 4 terms of this pattern, -1 is the first term, common ratio is -2, easy peasy, -1, 2, -4, 8, right? Done. And the nth term, A sub n, will be -1 times -2 raised to n minus 1 power. Very, very important that you surround the R in parentheses. Because then you'd be distributing the order of operations otherwise, right? Then you will be written 2 to that power, not negative. So the whole thing, -2 has got to be raised to that power. So be incredibly OCD with the parentheses. If you want to put a parenthesis on -1, go for it. No harm. But better to be safe than sorry, and just make sure you use a lot of parentheses if you need to. So questions on the first page? We're good? Okay, let's keep moving. Let's keep on trucking here. Okay. So find the formula for the geometric sequence here. What's the 9th term? And then the next one, the 4th term is 125, 10th term is 125 over 60, 125 over 64. Find the 14th term. Okay, why don't you guys try that on your own? I'll give you guys a couple minutes. I'm going to freeze my screen. We'll see if we get the same thing. 3 should be pretty easy. 4 is a little bit more advanced, but I trust you guys can do both just fine. You may need a calculator.
For the fourth term. So it's probably 1,000. So it's 1,000 times from 2 to the negative.
Hold on, just some deep thought. Give me a sec. I'll be with you in 1 sec. Come on, Brady.
It's 1/16. It's 2 to the 664.
One 25 times.
Oh, wait, 14 and then
2,000.
multiply 1/2.
Wait, 2,000.
Hey, Barry, go ahead.
We have to like start at the first.
No, not necessarily. No,
We do. For,
start wherever you like.
we start like that term and then so and
Totally. What do you prefer? Yep. All right, here we go, guys. Here's what I got.
So A sub n is 5 times 3 to the minus 1 power. Obviously, you want the ninth term, n to have 9, 3 to the eighth power. I don't know if that's not that's the calculator. And then for 4, that's a little more tricky, but not too bad. If you just think about like you visualize it. I mean, you don't have to do what I did. That's a little bit more labor intensive, but help you visualize it. You're going from 125 to 125 to 61. How many jumps am I making? So like 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So that means that 125 to the R6, 1 over 64. R6 1 over 64, R is 1/2. That's a nice perfect 6 root. And then you can use it. Find the 14th term. You have a few options. If you want to find the first term, go ahead. Ready to ask about that. Actually, I've seen this in the past where like they feel they have to use that formula A sub n equals A sub 1. They got 5 solve A sub 1 first. And if you get too formula intensive, I say forget that. Just start wherever you want. Start with the 4th term. How many jumps you have to make to get from the 4th term to the 14th term? 10 jumps. Or if you want to start with the 10th term, that's fine too. How many jumps to make from the 10th to the 14th? 4 jumps, right? Meaning multiply R by 4. Totally up to you what you want to do. But I figured let's just start with the 4th term, jump to the 14th term. 1/2 to the 10th term is, 1024. 1 over 1024, sorry. Times 125 to get that. So we're okay with that. Again, use like logic. You don't have to get so formula intensive, right? I trust you guys can do logic just fine. All right, let's keep moving. Okay, series now. So we're done talking about sequence. I mean, there's other cool stuff we can do with sequences. I have some really juicy problems, but series. Now we're going to talk about adding, right? You're adding a bunch of these. In fact, actually, I think this is kind of a cooler thing. For example, does anyone like play the stock market or look at retirement accounts or college savings or like? Do you guys know college savings? Well, let's talk about yeah, let's talk about what IRA is. An IRA, an IRA account. Yeah, there you go. You guys might are day trading or something else here. So I'm thinking more one, so I'm 46 years old. You're take more risk for an animal. But like for example, when you have a job, you guys are in the workforce, like a company will give you a retirement plan. Usually every month they put money in the retirement plan. And that money grows, right? But the thing is that let's say your money grows 10% a year. That's really good. Let's say you start $10,000, put $10,000 account, and then the tax season, you got to put that $10,000. But the thing is that year one, so let me write this out on the board here. Year one, let's say you're fresh out of college, you get put money in your account, and after year two, let's say your money grows 10%. How much money you got now? 11 grand. However, you're gonna put in another 10 grand, right? Because you can't. If you want to. That's actually a really smart decision, professional. Strong encourage you guys to do. Okay, year three, that's 21 grand, right? But here's the thing, that 11,000 came from here. So this 11,000 sees R how many times? Twice, right? Because it came from, but this only has been in the account for a year now, right? So what's gonna happen is that, fine, you got $21,000 times 1.1, and then you have another 10 grand. What's happening is that this is actually like a geometric series, right? Like you see here. You have A1, that's your first term, then A1R, A1R squared, A1R cubed. Think of this as your first year of investment. Or heck, let's say your parents gave you like 10 grand. So, oh, here's 10,000, put in this in a savings account, take care of yourself, right? And then let's say the year after, maybe your grandparents or someone else or an uncle gave you money. So now their money grows, but it have one less year of growth because it was in there one less year than the previous investment, right? So that's what a geometric series is kind of like. It's kind of like you're adding money as every year passes, but sometimes some of the money gets more growth than others. So you have to do it as a series because you're adding up all those amounts from all those years. That's a kind of a tangible example and very important financial example with a geometric series. So that's what's happening, is that you're adding up all these terms. And some get multiplied by R many times, some don't, just depending how long it's sitting, right? So in sigma notation, how can I write it? You can write it like this. We'll use I. I'll say I equals 1. And this will be infinity. You have A sub 1 times R raised to the, hold on a sec. Use that, sorry guys. My apologies. Let me use that. N or N minus 1? Yes, N minus 1. No, you're correct. You're correct. Right. Right. Yeah, because initially you start with A1. You're correct. Yes, you're correct. You're correct. Sorry, that was kind of a little slow there. And then this one, actually, let me back up a little bit here. I'm gonna call this K. My apologies. I should have consulted my notes. I'm gonna let N equal the number of years or the number of terms, right? That's usually what N equals. So sorry about that. Hopefully I didn't confuse you guys. So usually when the iteration of each term, like, if you have like subscripts or whatever, I'll call it K or I or J, that's usually the letters used. But if it's infinite, it goes on forever. If it's finite, we stop it at whatever N is. N's the number of terms. So we're gonna write the following in sigma notation. So I'm gonna do this. K equals 1. What's my first term? 1. What's my ratio here? 2. K minus 1. How many terms do you think we have? What do you guys think? If I'm multiplying by 2, I'm going from 1 to 128. I think it's 8. Is it? No, you're. But I think it's 8 terms though. Oh. I think it's 8. Yeah, the reason why it's 8 is because here's the reason why it's 8. Because the first term, sorry, the last one divided by the first term is 2 to the n minus 1. So you need 2 to the 7th power. You're correct, but n's gonna be 8 as a result. Yeah, it's a little tricky. So you have to kind of do that plus 1. Same thing here. K equals 1. What's the first term's 2? 2. What's the common ratio, guys? Yeah, it's gonna be an alternating. We call it an alternating series, by the way. K minus 1, and
30 on 25. Hold on. Give me a sec here. I think it's gonna be 6. Oh, it is 6, duh. Obviously, sorry. I like calculate. Of course it's 6. The 6 terms. There you go. So we're okay with that? Right. Go and try C and D on your own. And we'll compare. I'll freeze my screen for a moment. Exactly. And by the way, if you see dot 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 at the end, what do you assume you can put a top? Infinity, right? So C will be an infinite series for sure. And feel free to use your fingers if you need to. Okay, here's what I got.
3/6, right? You get negative 2/3, positive 2/9, and negative 3/6. Okay.
Okay, let's keep on trucking here. All right, page 3. The sum. Here's the sum of the geometric series. So it's this. So as I was talking about,
If you invest money in a retirement account, say from 10,000 a year, you can use this formula, right? Actually, it's kind of a fun little
exercise to see. So I'm going to encourage you guys to invest your money wisely. We should actually to have a business class here. I think it'd be fun. Who teaches econ here, by the way? Business Hunter or Sauls? Yeah. I'm sure you guys, hopefully there's a discussion on that. But here's a formula. It looks a little funky. It's kind of hard to use intuition to figure out why it works. We did have a formal derivation of it for the arithmetic series. Like, it wasn't too formal, just it made sense, right? A little hard to make sense of this one. But that's what it comes out to. It comes out to that if you were to, and I think there is a formal proof. I just can't remember exactly how it works. Actually, we are going to do it. Shoot. And I don't remember how to do it. Crap. Okay. I'm going to wing it with you guys. Let's see. All right. Anyway, before we do this, let's just you don't have to write this down, but just for fun, let's say you start 10 grand in an account, right? So $10,000. And let's say your money grows 10% a year. If your money grows 10% a year, what are you going to let R equal, by the way? And please don't say 0.1. If 1.1, because if you think R 0.1, is your money growing or decaying? By how much? Yeah, you're losing a lot of money at that point. You're gonna go broke, right? So anyhow, okay. So if I were to work this out, I'd do 10,000 times. Now let's say you're out of grad school. Maybe you go to college. You're 22. You decided to go to grad school. You're 25 years old, right? And you're gonna work for 40 years, so you're 65. You want to retire when you're 65, right? So we would do 1 minus 1.1 raised to the 40th power divided by 1 minus 1.1. How much money is that, guys?
That's $4 million. That's $4.4 billion with age 65. Just by putting 10 grand. 10 grand a year, you're age 25. So I guess of course there's inflation, you know, like houses here used to cost like, actually now house now probably in the early 90s, probably not $1 million. Now it's like $50 million. Crazy. But anyway, that's a good, but then you feel comfortable, like, yeah, I got $4.4 million, maybe $100,000 to live, or that, maybe 40 years from now, maybe $200,000 to
Live comfortably. But you could probably live comfortably for another 20 years, to hopefully die by 85, not that you're kind of screwed. I don't know. Or maybe your money keeps growing. Your money keeps growing as time passes. So you keep investing it. Anyway. But just by 10,000 a year, that's kind of interesting, right? So, all right, let's work out these formulas though. These are not as fun, but let's do it, right? So, what's A1 here? What's A1 going to be? What's R going to be? So let's do the formula. Oh, and how many terms do we want? 10 terms, right? So you do 2 times 1 minus, be careful here. Get that in parentheses, right? Raised to the 10 power. Please be careful. This one we'll do a little more quickly. If you work that out, let's see. Negative 0.25 raised to the 10 power, 1 minus that number, divide by 1.25 times 2. You roughly get 1.6, I think. 1.6. Yeah, I think you get 1.6 roughly. Yeah, let's flip it. Yeah, you get about 1.6. By the way,
what if I change that to infinity? Change to someone chain touch or part A? Why not? Yes. Yeah, exactly. What's going to happen is that the terms, the sequence, each subsequent term in the sequence, not series, in the sequence, like the 20th term is going to be super small, right? Because now you're multiplying 2 by -1/4 raised to the 20th power, 20th term. So ultimately, these terms you're adding on are so minuscule, they're negligible, right? To the grand scheme of things. So ultimately, the sum will converge to 1.6. And that's what you guys work with in BC next year, when you guys start doing series, which you're doing right now in their class. Talk about convergence office. Likewise with this one too. You have 16 times 1 minus half raised to the 10 power, or 1 minus half. You are correct. It is 8. I am wrong. Thank you, Pam, for catching that. Yes, first term is 8. Thank you. And just work it out. Let's see here. 1 minus that number, divided by 0.5 times 8. You get close to 16, I think. I get 15.98. Yeah, totally. Yep. Because when you plug 1 in for K, the first term is 8. The difference between these two, what the exponents, I minus 1. Right? I didn't see that either.
Initially. Until Pan corrected me. And by the way, if you want to check your work, hit alpha window, option 2. You can use X or any letter you want. 1, 10, 16. There we go. To be honest with you, I don't remember how to derive it. Let's come back to that later, because I don't want to do something kind of silly and it just doesn't work itself out. But let's jump to the 4th page. I'm going to tell you right now that when you have an infinite series, right, you have an infinite series. If your R is less than 1, or the absolute of R is less than 1, so it's basically between -1 and 1, non-inclusive, then the sum will be this. Which kind of makes sense, right? Because what do we have originally? And don't write this down, but y Actually, do write this down. Sorry. Do write this down. Y R to the N approaches 0 when N approaches infinity if R is between -1 and 1. That's probably the neatest I've ever written.
But, I'll never write this neat. But R to the N approaches 0 when N approaches infinity if R is between -1 and 1. So that just goes away. That R to the N term
Vanishes. Leaving you with just this. Leaving it just that. So that's an infinite geometric series that converges. I mean, you could write an infinite series that doesn't converge. That's fine. But the sum of infinite geometric series that converges. I'm going to use that term a lot with you guys because that's just something you have to be very comfortable with as we move on to AP Calculus BC. That converges. Okay. So let's do it. What's your first term here? Yes. What's your R? Perfect. And there you go. Which is 1 over 0.6 or 5/3. 5/3, right? What's your first term here? Not -2. Oh, sorry, it is -2. Sorry. I thought you said -10. Yes. Sorry, I'm just a little sleep deprived. Yes, there we go. And what's the R? Good. -2.5, I think. Yep. Okay. If you have 0.1 repeating, how would you write that as a rational number? What do you guys think? Yeah, this is kind of a funny question. Because it's like saying this, right? 0.1 plus 0.01 plus 0.001 plus 0.0001 and so forth, right? So is this a geometric series? It is. It is. What's the R value? What's the A value? A1, sorry. It's 0.1 also, yeah. So this is actually that's totally infinite geometric series. So yeah, A1 is 0.1, R is 0.1. So guess what? 0.1 over 1 minus 0.1. 0.1. Hold on a sec. Over a point. Yes, you get 1/9. There you go. Sorry, I just had to make sure it made sense. So yeah, you get 1/9. I think most of you guys hopefully saw that. It's like 0.2 repeats 2/9, 0.3 is 3/9, or 0.4 is 4/9. 1 minus R if it's infinite, and R is between -1 and 1. Two things: has to be infinite, and R is between -1 and 1. Yeah. Okay. Just what I was talking about. Okay, I love this problem. This is our last problem for today. Increasing annuity. Okay. A deposit of $50 on the first day of each month, and an account pays 3% compound monthly. Was bounced at the end of 2 years. This type of saving plan is called an increasing annuity. So how many payments are we making, guys? Just 24 payments. Yeah. So your A1 is 50, right? What's your R value, guys? Yeah, don't write 0.03, you lose, then you lose 97%. Right? That's not good. And your N's going to be 24. So how much money do I got? Well, let's figure it out. 50, 1 minus 1.03 raised to the 24 power. Yeah, go ahead. No, because I did 24. No, if you kept time in years, yes, you have to do some. You have to do an adjustment like that. But no, because the 3% I know why you're saying that.
Because usually, when they sell these financial products, they say, hey, you know, there's a, like, an annual increase, or like 10% rate, like usually it's 30%, and then that's 5 and 12. So the 3% is actually, yeah. But no, I know what you're saying.
That's usually how it's marketed, but for the sake of this problem, we're, yeah. Oh yeah, duh. Sorry. Yes, go ahead. Yeah.
Isn't the rate 1.03 like the R?
Yes, exactly. Yes, R, because that's what you're multiplying each term by.
So then in the on the bottom, it should be 1 minus 1.
Yeah, I made a mistake. Yeah, I goofed. So you should have about $1,700. Now, what if you didn't do this? What if you just took $50 and put it under your mattress, right? Okay, or just put it in a cookie jar or something like that. If you didn't invest it, if you didn't invest your money,
If you just look like, let's say you get an allowance of $50, right? And you just do it again, just, or you work at some place, maybe like, maybe you work at a restaurant, it's there, I don't know. Or some store, who knows? But you put on your mattress at $400, that seems nicer, nice $520. I don't know, only 3%, that's not asking too much, so.
seems nice to me. So anyway, just, you know, financial sense, right? You know, invest your money. We'll stop there for today. I just can't remember the derivation. I don't want to just, if I figure it out, I'll tell you guys next week. Homework. Let me reduce it again.
Is that for what?
Yeah, I'm gonna reduce the problem, right? I'm gonna drop like 40.
It is fine. So weird.
I mean, you guys need to-
Your children at 6:30. What you do to do it?
Oh, yeah, they're actually-
Fix them up.
You don't need something with them. Yes, it is. It's not.
Yeah, I'll take a deal. Oh, we're the scapegoat right there. He actually was just like. Things are looking quiet right now. It's time to be gone. Jake's is missing. It's always.
Jake's is still on.
Oh, so bad.
When I hear police control out here. It's not.
That's what it's not gonna do.
I know it's.
Oh, yeah. Yeah, I know.
I'm not waiting on this. So like.
Yeah, these are fun watching.
My shoulders are. You know, it's my tricep. It's not. It's like this stage that it's important. Yeah.
Everything to cross out. I did the opposite. I circled like my- Why not just cross the one? You don't have a great reference.
I don't know. Yeah.
This is mine.
Yeah, I took out 10 problems, guys.
Or if you would allow for an eight.
Which one looks the worst? Oh, shoot.
So next week or.
Do you
Yes.
ever just like?
No, I.
you're so tired.
It's the first meeting of this Sunday.
That's the last time.
Do a lot of calls.
I didn't speak.
Oh, yeah. Oh.
I don't know.
I didn't understand.
Wait, this is the exact same sequence as the one that. Okay.